My name is Ron. I'm a smart guy. I'm so smart, I know how dumb I am now. Okay? Back in 2014, I made a circuit that could drive the light bulbs I have all over my home. And this is one of those light bulbs. It requires 8.5 watts from mains power to drive that little appliance. And I made that circuit, and I piled it up and I put it into a plastic container, a pill bottle like this. Mainly I did it to show off, to show that I could get an effective 110 volts into this thing using just battery power, small batteries. But I encased it solidly in plastic. There's no air movement in this thing. And it occurs to me that the circuit is using 3.5 watts to light that light bulb up effectively when I use my rechargeable battery pack, like this one. Now that's all well and good, but you know, I know what this is, but nobody else knows what this thing is. And there's no instructions on it. What if somebody else gets a hold of it? That circuit inside is got cardboard separators, and I also packed it with styrofoam, which are quite flammable. So what I've done today is I got 2 kitchen thermometers, and I'm going to test the trapped heat inside my little plastic lamp. And I'm going to overdrive the circuit. I'm not going to use my batteries because I want to run as long as I need to find out how hot that can get inside that bottle if you don't let any heat out. Because if you consume 3 watts and trap it, the air inside that small space should heat up. So I'm going to overdrive it by using a 12 volt AC/DC converter, kind you can get anywhere. This one comes from Goodwill. And because I'm using more voltage than I would with my battery pack, because those batteries are only 1.2 volt batteries, at best they can contain 10.5 volts in an entire package like this. 8 batteries only come in about 10.5 volts. So this was made for 10.5 volts. Nobody else on earth knows that. They also don't know that it's packed with flammable material. So I am going to run it from the wall, and the AC/DC supply is 12 volts, and so that's going to push more current in to the bottle, and it's going to be about 5 watts. So it's going to be more than I intended, but still, good experiment. I have 2 thermometers here. They're both out in open air right now. They're both the same model, same battery inside. One is to track the air temperature, and one's going to track the temperature inside the bottle, because I have drilled a small hole into the air cavity between the coil at the bottom and the transistor near the top. And what I'm going to do is, first off, I can see right now that this temperature probe for the air reads 1 degree higher than the one I'm going to stick inside the bottle. So I seem to be 1 degree off to start with, but that's okay. It'll be close enough for government work. I'm going to place my probe into my bottle, and I'm working it around the components until it hits the opposite wall. So the probe is all the way in the bottle. And I'm waiting just a second. I can see that the temperature has already jumped to 68 degrees inside the bottle, even though it's 67 out here. Oh, then these things turn off after a minute. Great. And it looks like the inside of the bottle is slightly warmer than the outside air by 2 degrees. That's interesting. I haven't used it yet. Okay. Well, That's still good enough. Let's turn it on. Do 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 do. The bulb is lit. I'm using between 400 and 410 milliamps. In fact, I'll zoom in on that for you. You can see yourself. About 400 milliamps, and the battery supply is about 12.3 volts. So that's about an even 5 watts of energy are going into the bottle lamp. And I'm going to start a count up timer. I'm going to see how hot it gets inside that bottle, how quick. So we'll come back after a little while, see how it's doing. Okay, we're back a scant 10 minutes later, and the bottle is at 83 degrees as compared to 67 air temperature degrees. So let's go a little longer. Be back in, oh, I don't know, another 10-20 minutes. Checking in again. It's been 20 minutes of time. We're up to 90 degrees inside the bottle. And climbing. Okay. Let's check in one more time later on. Back for a third visit. It's 30 minutes total. The bottle has gotten up to 93 degrees. Might be plateauing. Of course, the act of sticking a skewer through the bottle is probably altering the experiment by letting some of that heat come back out through the temperature probe. It's not as bad as I thought. I'm going to go a while longer, see how hot this bottle will get. Okay, it's been 1 hour. I've been trying to wait for the internal bottle temperature to get up to 97 degrees. But it's been holding here at 96 for quite some time. It looks like this is the plateau. Doesn't seem to be getting any warmer. The bottle is barely warm to the touch, even though it's 96 degrees. But I do have to say that the AC-DC converter plugged into the wall is about as warm as the bottle lamp. So, not bad. It's not as bad as I thought it was. It's been 1 hour and 6 minutes, officially calling the experiment over. The bottle only went up 20 degrees outside air temperature and no more. So not bad. Not as bad as I thought it was. So in conclusion, I should be more careful to label the electronic circuits I make, and also not to use flammable materials inside them. And you should be more careful too. I have been fooling with silicone caulking. This is type 1 silicone. It's the kind that smells like acetic acid when it cures. And I have been able to form it into shapes. So silicone would be a nice divider inside a lamp circuit like this. So I'm going to step up my game and use safer materials in my projects, and I hope you do too. See ya.